compounds, the chemical properties of carbon compounds. Now, the first property that we are going to learn is combustion. Combustion means burning in oxygen. Okay, boys, kindly remember when carbon or its compounds, they burn in oxygen, right? You get carbon dioxide, heat, and light. Carbon dioxide plus heat and light. So carbon plus oxygen will give you carbon dioxide plus heat plus light. See this, boys, the first one. Carbon plus oxygen gives you carbon dioxide plus heat plus light. Now suppose I talk about methane. Methane is also a carbon compound, boys. Is methane a carbon compound? Yes, methane is also a carbon compound. So what is the formula for methane? The formula for methane is CH4. So when I burn CH4, that is methane in air, that is oxygen, I get carbon dioxide. Now here there is also water plus heat plus light. Is that clear? So you get water, carbon dioxide, heat plus light. I did not mention water initially. That is because I did carbon plus oxygen. In carbon plus oxygen, you get carbon dioxide, heat plus light. So suppose you have a carbon compound, that is a hydrocarbon or other carbon compounds. They burn in oxygen to give carbon dioxide, to give water plus heat plus light. And the last one is ethanol. Ethanol, which you have to study, ethyl alcohol. Okay, the formula for ethyl alcohol is C2H5OH. C2H5OH. It burns in oxygen. So you get O2. This product you should know. Carbon dioxide, water, heat, light. Carbon dioxide, water, heat, light. So this is my first property, combustion. Okay, combustion means to burn in oxygen. Okay, or in air. So it burns in the oxygen in the air to form what? It forms carbon dioxide, it forms water, it forms heat and light. Okay, carbon burns in oxygen to form carbon dioxide, heat and light. Is this point very clear? Okay, now the second one is oxidation reaction. As you know, oxidation means addition of oxygen, right? So carbon compounds like alcohols, okay, we will talk first about ethyl alcohol, are oxidized to form carboxylic acid, okay, with oxidizing agents like potassium permanganate or potassium dichromate. So acidified potassium dichromate or alkaline potassium permanganate, that is KMNO4, reacts with alcohol to give you what? To give you carboxylic acid. Do you know what is the formula for carboxylic acid? Do you remember we have studied carboxylic acid? Do you remember the formula for carboxylic acid? What is the functional group for carboxylic acid? It is COOH, carboxylic acid. Do you remember? C double bond O single bond OH, carboxylic acid. Do you remember this? So this is my ethanol, ethyl alcohol in the presence of alkaline KMNO4. It's the oxidizing agent. It's what brings about oxidation. So the oxygen is added to the ethyl alcohol and you get ethanoic acid. Ethanoic acid is also commonly known as acetic acid. Is that clear? It is also commonly known as acetic acid, right? Now, so this is the formula they are giving you. C2H5OH, okay, gives you ethanoic acid, CH3COOH. Do you remember we had written this? This is my carbon, right, with my 3 hydrogens, 3 places I told you, attached to another carbon. This carbon is double bonded here and this is single bond OH, COOH. This is my carboxylic acid. You remember when I said carboxylic acid, I put the tag, the suffix as oic, OIC. Now because there are 2 carbons, it is derived from ethane. right? So you got ethanoic acid, right? Now my ethanol, you remember this was my ethane, C2H6, right? Now this one hydrogen, okay, it gets removed, you get H5, correct? And here you get OH, so C2H5OH. This is my ethanol, okay, also known as ethyl alcohol. Okay, now the next one, addition reaction. This is the simplest reaction. Okay, please look at this. Unsaturated hydrocarbons. Unsaturated hydrocarbons are those which contain carbon carbon double bond, right? So what happens is this double bond gets broken, correct? Sorry, this double bond gets broken. Okay, and here we have a single bond, correct? And this here you have the structure like this way, right? To and from an unsaturated or a double bond carbon compound, it becomes a single bond carbon compound, correct? So ethene, the formula for ethene, can somebody give me the formula for ethene? You remember ethene, I explained to you, C double bond, C single bond, H, 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 and H, C2H4. Do you remember this?
Yes, miss.
So this is my ethene, right? Now, ethene reacts or acts with hydrogen. It acts with hydrogen, correct? Correct. Now what happens is this bond breaks, so you will have this like this, and one hydrogen comes here and one hydrogen comes here. Now can you tell me what does this become? What does this become if one hydrogen goes here and one hydrogen goes here? One hydrogen goes here and one hydrogen goes here. What does this become, boys? Can you tell me what it becomes? Can you tell me what does it get converted to? What is this, boys? Can you explain to me? What is this? What compound is this, boys? Come on, boys.
Miss C2H6.
Yes. What is C2H6?
Ethane.
Ethane. Yes. So ethene gets converted to ethane. Now, ethene is an unsaturated hydrocarbon. It gets converted to ethane, which is a saturated hydrocarbon. Is that clear, boys?
Yes, ma'am.
So see this reaction. C2H4. You understood why I showed you that? I wanted
Yes,
to
ma'am.
show you that this is the double bond. Okay. This gets cancelled. Okay. And you
Miss,
get,
the double bond gets removed and becomes a single bond, right?
yes, single bond. And here you have this, where these two places that are there where your hydrogen goes and attaches. Okay. This is whenever there is nickel or palladium as a catalyst. So ethene undergoes addition reaction to form ethane. Correct. Now next one, see the next one. Look at this. Right, this is the same thing which I have written, correct? I've written it like this, right? This is not 2. Okay, it's the same one. It is, I've written it, I've just split it up and written it. This is my structure, this is my ethene, right, which gives me ethane in the presence of nickel as a catalyst. It is not a different reaction, it is the same reaction, but I have split it out and written it. Is that clear, boys? Okay, next one.
Yes,
The
ma'am.
addition of hydrogen to unsaturated hydrocarbons forms saturated hydrocarbons. So, whenever you add hydrogen to an unsaturated hydrocarbon, you get a saturated hydrocarbon. This process is known as hydrogenation. This process is known as hydrogenation. So what is hydrogenation, boys? Your unsaturated hydrocarbon gets converted to saturated hydrocarbons. How? By the addition of hydrogen. By the addition of hydrogen, right? Hydrogenation is used to convert unsaturated oils and fats to saturated oils and fats. Okay. Now, the molecules of vegetable oil, okay, what happens is they contain long and unsaturated carbon chains, right? And when you hydrogenate, when you add hydrogen to them, it gets transformed into saturated chains. And that's how you form vanaspati ghee. Okay, the vegetable ghee that is formed, which is formed from plant products. Okay. Now, unsaturated fats containing double bonds are healthy, while saturated fats are harmful to health. Right? That is why it is better to eat that cow's ghee and all than to eat vanaspati ghee. Right? Of course, even the cow ghee is not really great, but this is the thing, that vegetable oil, okay, when you transform them into ghee by hydrogenating them, the saturated chain is formed from an unsaturated chain, right? And these unsaturated fats are healthy, whereas the saturated fats are harmful to health. So the vanaspati ghee, which sometimes you people have, okay, vegetable ghee as they call it, okay, is harmful to health. Okay, I'll show you a picture at the end of this vanaspati ghee. I'll just get it on this thing and show you. Maybe you'll be aware in case you're using it in your houses. It is harmful to have. It is better to have oil or animal fat, that is cow's ghee or whatever. Those are better as compared to vegetable oils, vegetable fat, correct? Vegetable fat, not vegetable oil. Okay, so this is my vegetable oil. In the presence of hydrogen, it gets converted into vegetable ghee, which is saturated. Okay, I'll show you this, right? So saturated hydrocarbons are not good for health at all. The last reaction is the substitution reaction. Very, very simple, right? They undergo substitution reaction with help of halogens, right, to form substitution products. Now, what is the meaning of saturated hydrocarbons? Simplest saturated hydrocarbon is methane. What is the simplest saturated hydrocarbon? Methane, right? So, what happens to methane? See here with the chlorine. Now, all of you pay attention. Look at this carefully. Look at this. Is my carbon. 1, 2, 3, 4. Correct? Correct? Am I right, boys? I'll have hydrogen, 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 and hydrogen. Is this clear?
Yes, ma'am.
Okay, now when I
Yes,
add
ma'am.
chlorine to it, see stepwise what happens. So beautiful this reaction is. This hydrogen is replaced by one of the chlorine, right? So this hydrogen, what happens? Just watch here. This hydrogen goes away, okay? And you get a chlorine out here. And what happens is this hydrogen mixes with that chlorine and you get HCl. Right? So that's what they showed you. CH3Cl, CH3Cl plus HCl. Right? Now, can you tell me the name of this? This is methyl chloride. What is that? Methyl chloride. Right? Plus HCl. Now, what happens in the second step? This methyl chloride, once again, it reacts with chlorine. So this is my methyl chloride. Right? This is my methyl chloride. Now we've got methyl chloride. Okay. It is mixing with this chlorine. And what is happening to it is this methyl chloride. This is also getting replaced. Correct? And you will get one more chlorine out here and then you'll get the HCl. Correct? That is the second one. What is the second one? This is my CH3. This is CH3Cl. This is just one extra step. We have this thing. Right? Plus HCl gives me. Okay, see, this is the second one. CH3Cl. This is first. Sorry, boys. This is the first one. Boys, pay attention. This is the first one. then this reaction occurs. Correct? So what happens is CH3Cl plus Cl2. What do you get? CH2Cl2 plus HCl. Now only common sense will tell you, if you add one more chlorine to this, what is going to happen? Can you tell me what is going to happen if you add one more chlorine to this? This one more will disappear and we'll get one more chlorine out here. Correct or no? Correct? Am I right? So this will give you CHCl3. This is the third reaction. CHCl3, reaction number 3. Correct? And HCl. And last, when you replace one more, what happens to it? Tell me. It is very simple. You get CCl4. Correct? Yes or no? CCl4 plus HCl. Right? This is known as chlorination of methane. This is known as chlorination of methane. So these reactions are little up and down. This is first here, then second, then third, and last is fourth. Did you understand how this reaction is carried out? Okay, this is known as substitution reaction. What type of reaction is this known as? Substitution reaction. Is this clear, boys?
Yes, ma'am.
Okay. Now, some important carbon compounds. Ethanol. Ethanol is also known as ethyl alcohol. Ethanol is the IUPAC name. Okay, so ethanol, right? It is also known as ethyl alcohol. That is the common name, ethyl alcohol. It is also called as alcohol, the normal alcohol that is used to make Beuda, drinking alcohol. Do you understand what I'm saying? It is also known as spirit. Correct? Always alcohols, the drinking alcohols that you get, the beer, the rum and all, they are known as spirits, right? Okay, so always they have a certain percentage of ethyl alcohol. Okay, they have a certain percentage of ethyl alcohol. At room temperature, colorless ethanol is a liquid, and its boiling point is 78 degrees Celsius. It is soluble in water. It can dissolve in water. Okay, you have mixed now whiskey with water. Have you mixed whiskey with water, boys? Or whiskey with soda? What do you mix whiskey with? Huh? Whiskey is mixed with water or soda. It dissolves in it, right? Yes or no?
Yes, miss.
They have rum and coke, correct? Yes or no? Do you see the rum separate and the coke separate? No, correct? So, it is soluble in water. It is neutral, right? Alcohol being a good solvent, yeah, it dissolves in everything. Rum, coke, Sprite, Limca, correct? Barabar? So, alcohols are used in medicine, such as tincture iodine. Okay, what is tincture iodine? It's a solution of iodine and ethanol, right? Now you have forgotten. We used to put one nice red medicine for you in the school if you fell down. In our days, they used to put. Now they don't put that tincture iodine anymore, right? This is bluish in color, right? Cough mixtures contain certain percentage of alcohol. That is why when you have a cough syrup, generally you feel sleepy. Okay, and also in many tonics, right? So these are the properties of ethanol. What is ethanol used to make? Achha, now let's first study the chemical properties of ethanol. Now tell me, ethanol is a hydrocarbon. Am I right? Yes or no?
Yes, ma'am.
So ethanol will react with oxygen to form what? Just now we mentioned. Ethanol mixes with oxygen to give what? Carbon dioxide, water,
and energy.
light and heat, right? So now all alcohols react with sodium metal. This is C2H5OH, count 2 carbon, 5 hydrogen, OH. It reacts with hydrogen to give. Now this is very simple, boys. This hydrogen, no boys, it goes away and you get H2, and here the sodium goes and takes that place. So this is known as sodium ethoxide. What is it known as? Sodium ethoxide. And sodium and hydrogen gas is liberated. It's very simple. Organic chemistry reactions are very easy because it's, if you understand the base of it, what happens is, this is my ethyl alcohol. See, I'll draw the ethyl alcohol like this way. You remember I showed you, you had to write this CH3, bichara, correct? And then you had to write CH3. Then you write C and this 2H, correct? Yes or no? And this had this OH, correct? This had the OH. Now what happens is this OH, the H gets replaced, correct? And what goes in the place of H? What goes in the place of H which gets replaced? You get O and Na. What do you get? O and Na. So this is known as sodium ethoxide and hydrogen gas. So this hydrogen mixes, okay, it goes on the other side because here there are two hydrogen atoms, so you get sodium ethoxide and hydrogen. We have done one reaction before which you have not seen, right? What is our reaction which we have done before? We have done the reaction that ethyl alcohol or ethanol reacts with hydrogen with oxygen to form carbon dioxide, water, light and heat, right? Now this is very important, dehydration. Okay, what is this dehydration reaction? Dehydration means removal of water. Removal of water. So see this very carefully. Ethanol reacts with concentrated sulfuric acid to form ethene and water. So the H2SO4 is a dehydrating agent that removes water from alcohol. Now boys, look at this, CH3, CH2OH. इसमें से water निकाला तो क्या आ जाता है? You remove H2O. अभी इसमें क्या होता है? Now you read the this thing. If you remove H2O, remove H2O from here. Look at this and remove H2O. क्या हो जाता है? You get C and one more C. What is two C's? C2. Correct? Yes, boys. Boys, see, this is my formula. Can you see this formula? CH3. Now look at this. Look at this, boys. Still better, I'll just show you this. Look at this. Understand this carefully, boys. Understand this very carefully. Okay? Can you see this? This is my carbon. Okay? This is my CH3. Correct? Then you have CH2. And you have OH. Barabar? What we want to remove, boys, look at this. Look at this. Look at this carefully. Can I write it like this? I showed you how to write the structures. CH3, CH2, and OH. Correct? Boys, please understand. If I remove water, means I'm removing one hydrogen from here and I'm removing OH from here. Yes or no? What will happen? This will become a carbon double bond, na baba? Won't it become a carbon double bond? Come on, tell me what will be the structure if carbon double bond is removed. Can you tell me? What will be formed? Won't ethene be formed? What is C2H4, boys? What is C2H4? Boys, are you with me?
Miss, ethyl.
No, ethene. Ethene. It's also called as acid. Okay, don't worry. You just learn the IUPAC name. It is known as ethene. So ethanol reacts with concentrated sulfuric acid at 160 to 170 degrees Celsius to form ethene, and the water molecule is removed. Therefore, it is known as the dehydration reaction. Dehydration reaction. Please understand the reaction. The next one is your ethanoic acid, which is known as acetic acid. It is a carboxylic acid, right? 4% acetic acid. What is it, boys? What is 4% acetic acid? What is 4% acetic acid? Vinegar. Do you know what is vinegar?
Yes, ma'am.
You look at the vinegar bottle, you will notice that it is written 4% acetic acid. 4 to 6% acetic acid means 4 parts of acetic acid mixed in water gives you ethanoic acid, right? So ethanoic acid is a colorless liquid with a pungent smell and a sour taste, right? Pungent smell means you just take a whiff of ethanoic acid. You will notice it has a very, very peculiar odor. and a sour taste. It is soluble in water, right? It dissolves in water, right? That's why you can dissolve it to make vinegar, right? Vinegar is made by dissolving acetic acid in water, right? Now, a solution of 5 to 8% ethanoic acid in water is called as vinegar. Now, obviously, it's an acid, so it is acidic in nature and it turns blue litmus red. The melting point of pure ethanoic acid is 17 degrees Celsius and its boiling point is 118 degrees Celsius. Therefore, during winter in cold countries, right, ethanoic acid freezes at room temperature and it looks like ice, and hence it is named as glacial acetic acid. Now, ethanoic acid, once again, chemical properties of ethanoic acid, very important. Okay, what does it contain as its functional group? Carboxylic acid, COOH, carboxylic acid. Now, it's an acid, so it reacts with a base. Acid plus base gives me salt plus water. This is known as neutralization reaction. Correct? So it is a weak acid, right? Ethanoic acid is a weak acid. So it reacts with a strong base. Because it is a weak acid, it has to react only with a strong base. It cannot react with a weak base, right? And it gives you a basic salt, right? Because the base is strong. So it gives you a basic salt. Once again, very, very simple. Okay. If you know the formula for ethanoic acid, it is CH3COOH. Pay attention. CH3 COOH plus sodium hydroxide, NaOH. Boys, this OH mixes with this H and we get water. Am I right? We get water. Correct or no, boys? Okay.
Yes, ma'am.
And what is left here? You are left with CH3 COONA. What is this known as? This is known as sodium ethanoate. What is this known as? Sodium ethanoate. Correct? So let us just see the formula. Ethanoic acid, weak acid, reacts with a strong base, NaOH, to give you sodium ethanoate, CH3COONA, plus water molecule that is formed. Plus water molecule that is formed. Is that clear, boys?
Yes, ma'am.
Is that clear? Okay. Now, reaction with carbonates and bicarbonates. Ethanoic acid reacts with sodium carbonate or sodium bicarbonate to form a salt. Again, sodium ethanoate. Okay, but the difference is along with water, you also get carbon dioxide gas because there is a carbonate, boys, or a bicarbonate. Carbonate is, okay, H2CO3. Sodium carbonate, Na2CO3, and the bicarbonate is NaHCO3. So this is your sodium carbonate, this is your sodium bicarbonate. Only difference is along with the water, you also get the carbon dioxide gas. Okay, so ethanoic acid, CH3COOH, you don't have to learn these reactions back. You have to just remember and understand and write it 2-3 times. Plus sodium carbonate. What is the formula for sodium carbonate? Na2CO3 gives you 2CH3COONA plus carbon dioxide plus water. Again, ethanoic acid, CH3COOH plus NaHCO3, sodium bicarbonate, gives you sodium ethanoate, CH3COONA plus H2O plus carbon dioxide. Is this clear, boys? This is the most important reaction, which is known as esterification reaction. Esters are another group of carbon compounds. Okay, I explained to you what are esters. So whenever a carboxylic acid mixes with an alcohol, you get an ester, right? So ethanoic acid is my carboxylic acid. It reacts with ethanol, that is ethyl alcohol, in the presence of an acid catalyst, and an ester known as ethyl ethanoate is formed. An ester known as ethyl ethanoate is formed. So boys, pay attention. Very important reaction. Ethanol, very easy to remember. Ethanol, C2H5OH. Then acetic acid, CH3COOH, in the presence of an acid catalyst, concentrated sulfuric acid. See, boys, only the water molecule is removed. Can you see this H and this OH? It gets removed and it forms H2O, correct? And see what happens. Can you see this C2H5? Can you see C2H5 on this end? Can you see the O? And can you see the CH3COO? So CH3CO, okay, O, C2H5. This is known as ethyl ethanoate. It only seems like a lengthy reaction. It's very simple, boys. This hydrogen is there. It mixes with this OH and you get H2O. And here you get CH3COO, C2H5. This is known as ethyl ethanoate or ethyl acetate. Okay, this is an ester. So an ester has that OATE as the end. I'll repeat it tomorrow once again when I do IUPAC. Okay, this is another one which you have to learn. When ester, what is the ester here? Ethyl ethanoate reacts with sodium hydroxide. The sodium salt of carboxylic acid and the parent alcohol is formed. This is known as saponification. Which is the alcohol? The alcohol is ethanol. So this ethyl ethanoate, very simple, CH3COO, C2H5. It reacts with sodium hydroxide. You get sodium ethoxide. What is sodium ethoxide? Okay, not sodium ethoxide. You get sodium acetate. Okay, that is the carboxylic acid. Sodium salt of the carboxylic acid is formed, and the parent alcohol CH3COOO, CH3C CH2OH or C2H5OH. So ester, okay, that is my ethyl acetate reacting with sodium hydroxide, NaOH, to give you sodium acetate plus ethanol. Okay, what are the uses of ethyl alcohol, of acetic acid? Acetic acid is used to make vinegar. We've already said it before, right? There's nothing else which they have specified. Okay, so it is used 4%, 5 to 8% ethanoic acid in water is